project is about the chemistry of peanut brittle. This is the recipe, so of course before you start any chemistry problem, you need to know the ingredients and the procedure. So that's what this is for. Step 1 of the recipe is to combine the sugar, corn syrup, water, and salt and bring it to a boil on the stove. And while you're doing this, you should stir pretty much constantly. The chemistry behind this step is that peanut brittle relies on sugar in its non-crystalline form. So the first step separates sugar into fructose and dextrose, and this step requires acid, water, and heat. So in this situation, the salt acts as the acid, and the heat is from the stove. This reaction continues to take place as long as the sugar is and the acid are in a fluid state, which is part of why you need to keep it on the heat. Step 2 is to use a pastry brush dipped in water to brush away any sugar crystals that have formed on the side of the pan. So as the water converts to steam, the fructose and dextrose that came from the sugar begin to saturate the solution, increasing its tendency to form crystals and precipitate. Once the solution reaches a boil, the cool pockets formed by stirring can cause crystallization as well. So once it gets to this stage, you want to stir it less. And also at this stage, adding agents that interfere with crystallization is really helpful. The third step is to swirl the mixture occasionally until it reaches 238 degrees Fahrenheit on the candy thermometer, or 110 degrees Celsius. Once it's at that temperature, you stir in the nuts and continue to cook the mixture, stirring often so the nuts don't burn and the mixture becomes a uniform color. The chemistry behind this step is that sugar cooked to a certain temperature will always contain the same percentage of dissolved solids. Also, after adding the nuts, stirring constantly roasts the nuts and further saturates the sugar solution. Once the sugar solution reaches 155 degrees Celsius, which is below the temperature that sugar normally caramelizes, but the amino acids in the peanuts or whatever nut you choose to use contribute to the Maillard reaction. So once it's at that temperature, it's time to remove it from the heat because you don't want to burn the sugar. Once it's removed from the heat, you stir in the vanilla and baking soda, and the mixture foams up in the pan. And this happens because when the baking soda reacts with the heat that's in the sugar mixture, it creates carbon dioxide that aerates the caramel. And this is essential to making peanut brittle because if you didn't put the baking soda in, it wouldn't create carbon dioxide, which creates the little bubbles in the candy. So when you tried to bite on it, it wouldn't break. Whereas now when you bite on it, it breaks. The baking soda also raises the pH of the mixture, which again promotes the Maillard reaction. These are the calculations I did to figure out how much sodium carbonate, water, and carbon dioxide are created when you add the teaspoon of baking soda that the recipe requires. So what I found out was that the teaspoon of baking soda makes about 0.63 teaspoons of sodium carbonate, 0.015 fluid ounces of water, and about 3.9 times 10 to the negative fifth cubic feet of of carbon dioxide. These are definitions of words that were in the explanations, and these are my sources.